So regression is all well and good and always really exciting, at least for economists, to get results out of your model. But if you really want to talk about the effects of policies or really understand the nature of how something causes an effect on something else, that all comes down to study design. And for a good study design, you need to have some kind of random variation to discover causality. Sometimes economists will say exogenous variation, and that just means that there's variation in your independent variable that isn't totally selected by the participants. In the social sciences, it's often really hard to conduct laboratory studies for good reasons. Sometimes it's cost related, other times it's ethics related. We may want to know the effect of education on earnings, let's say, but it would be pretty terrible to randomly assign people to get no education. So we don't want to do that. Instead, we want to look for natural experiments that help us to understand the effect of some policy or some phenomenon on an outcome that we care about in health economics. So here's one naive approach to study design. You compare subjects before and after. Sometimes this is called a pre-post design because you're just looking before some event and then you compare it to what happened afterward. So let's say, for example, some city council in a small town decides that they want to start a campaign to reduce diabetes. Totally noble public health goal. So they decide to put up ads around town, encouraging people to drink less soda. And that seems pretty reasonable. We know soda is associated, well, sugar is associated with diabetes, so this makes some sense. So now they want to know, did this do anything? Was it worth our time and money to run this ad campaign? And so one way to look at it is you could say, well, was the prevalence of diabetes lower after the campaign than it was before? And so let's suppose that that were the case. So after the campaign, we're like, oh, okay, so 25% of our population has diabetes, and before it was 29%. So the question that every researcher has to ask is, did this campaign actually reduce diabetes? Many of you will probably guess that this is, in the view of social science researchers, not necessarily enough. So the conclusion here is that it's really impossible to know because there are so many other possible explanations that are confounded by just doing a pre-post analysis. So, for example, maybe people started exercising more nationwide, including in this town, and so there was just a general trend towards better health behaviors, and the ad campaign had nothing to do with the differences that we measured. Another possibility could be the federal government started taxing sugar and soda companies raised their prices, which incidentally, tying back to earlier in the class, this is a change in quantity demanded. And so if we've got a change in quantity demanded, people are demanding less soda, they're consuming less sugar, which has a positive effect, or I should say a positive health effect on diabetes. But that doesn't really have anything to do with the ad campaign that the city council launched. And you can come up with all kinds of things. So maybe Russian bots started attacking distribution centers of Coca-Cola, and that created a big challenge in trying to actually get the soda that you wanted. You can come up with any number of things. So the important thing to take away here is that you have to control for baseline factors with some comparison group. And it's ideal if your comparison group had exposure to all this other kind of stuff, but not the ad campaign. So a basic study design would be a pre-post with treatment and control. So you compare the treatment group to the control group, both before and after something happens. And the something in our case that we're just talking about was a city council diabetes reduction campaign. So the control group that you have will estimate trends that also affect the treatment group, all of those sorts of baseline things that I was saying, nationwide get healthy campaigns, anything like that. And moreover, you also need this pre-period in order to measure the underlying difference between the treatment and control. So you could imagine that perhaps the treatment group, maybe city council in that town decided to address diabetes because they were worried about having a high baseline amount of diabetes, which means that other control groups might systematically be lower than the treatment group would be in terms of the prevalence of diabetes. And you wouldn't want to just compare the treatment and control group in the post period because you don't know where they started from. So this helps you to rule out any pre-existing differences between treatment and control group. So enter the diff and diff, as it is affectionately known. The difference and differences model is a workhorse in modern empirical research. And I'll show you, or I'll describe to you some of the basics of this approach. But know that there are also lots of ways to get fancy with it, with synthetic controls, and there's a lot of different ways to test it and make sure that all of the assumptions are met. So there's a lot to it, but let me explain to you the intuition. So first, you randomly split the sample into two groups. So you've got your treatment, you've got your control. That all sounds familiar. Now, let's measure the outcome in the pre-period for all subjects, which I alluded to on the last slide. Next, you give the treatment. And remember, treatment here isn't necessarily like a pill or physical therapy or some medical treatment. It just means, it can be the policy variable. It can be, some natural event. When we say treatment, we're just referring to whatever it is that we want to study the effect of. So you give the treatment to some subjects in the control group, or in the treatment group, excuse me, and then you measure the outcome in the post period for all subjects. So one of the key questions that you have to ask is, does a subject's outcome depend on receiving treatment? That is really what we want to know. Or is their outcome completely unrelated to receiving the treatment or the policy effect? So let's just do a practice question here. Suppose that, let's do another one here. A treatment, let's say, is the gym membership with personal training for the month of February. And here's the data that we record. In the control group, we measure that the average weight in January was, let's say, 156 pounds. And then we measure that the average weight in March is 147. We do the same thing for the treatment group. Let's take a look at the average weight in January. In this case, it was 152. And then the average weight in March was 148. So our question is, did gym membership lead to weight loss? We can see here that among the treatment group, we know that they certainly lost weight, but since we're smart enough to know that there are confounders, we also know that this information alone is not enough to make that conclusion. Let me pause for a minute here.